Section 3.5, Graphing Linear Equations in Slope-Intercept form. Slope-intercept form is probably a form of a line that you're familiar with. It's this equation right here, y equals mx plus b. It's not cleverly named. Slope-intercept form gets its name from the fact that m represents slope and b represents the y-intercept, hence slope-intercept form. Basically, it's y by itself equals a number times x plus another number. That's the general slope-intercept form. I have 4 examples down here of equations that are in slope-intercept form, and we can identify the slope and y-intercept from there. The first example, y equals x minus 3. Remember that the slope is the number that's multiplying the x, and if I don't see a coefficient, it must be the invisible coefficient that's in front of it, which is 1. The y-intercept, the b, is the number that's tacked on to the end. In this case, I have to make sure that it's a negative 3, because I'd be adding a negative 3. That's the same thing as subtracting 3. Let's move over to the right. Y equals negative 2/5 x plus 3. Your slope is the entire fraction. Your slope is negative 2 over 5. That's what's multiplying the x. Your slope does not include the x. That's just where you look for it. And your b, in this case, because it's positive, is a positive 3. That's from the addition of 3. Next example in the bottom left, y equals 6x. Well, this doesn't quite look like slope-intercept form. It seems to be missing the plus b. But I could really rewrite this as 6x plus 0. That's really what's happening there. I'm not adding anything onto the end that I can see, so I must be adding 0. Now it's pretty easy to spot that my slope would be 6, and my y-intercept would be 0. Take a very similar approach for the last example, y equals 8. We know that's the equation of a horizontal line, but it has no x. Well, in order to make that x disappear, we must have multiplied it by 0. So we're looking at y equals 8 is the same thing as y equals 0x plus 8. So there I have a slope of 0 and a y-intercept of 8. And that's all it comes down to. All right, that's just looking at the equation and identifying what's the slope and what's the y-intercept. All right, let's keep on moving. In terms of what slope is, it describes the steepness of a line. And there are 4 types of slope that we're going to consider. Positive slope goes up as the line moves from left to right. Negative slope goes down as the line moves from left to right. Positive up and to the right, negative down and to the right. Since we always read in English from left to right, it makes sense to consistently go from left to right when discussing slope. A horizontal line has a slope of 0, and a vertical line has an undefined slope. We want to avoid the phrase no slope because it can be ambiguous. When we say no slope, do we mean that there's no number we can assign to it and that it would therefore be undefined? Or by no, do we mean kind of the equivalent of none or 0, which would make it a slope of 0? So for that reason, we don't say no slope. We specifically say a slope of 0 if the line is horizontal and an undefined slope if the line is vertical. Also remember that vertical or horizontal would describe the lines themselves, whereas undefined and 0 would describe the slopes. Something to keep in mind. All right, so now let's see how we would find slope. So there are 3 methods that we can use to find slope, which we use m to abbreviate or to represent slope here. Non-vertical lines we know have vertical lines have an undefined slope. So we'll focus on non-vertical lines here, horizontal or diagonal. The first way we can do this using a graph is to think of slope as rise over run. Rise over run is going to ask us to look at a graph and then move accordingly. So on this graph, what I'm going to do is I'm going to start at one of my points. I'm going to start at the 3, negative 2. I'm going to start right here. And I'm going to count my steps to get up to 9, 2. I'm going to go 1, 2, 3, 4. I'm going up 4 steps. Now I'm going to go to the right. 1, 2, 3, 4, 5, 6. I've come to the right 6. Now slope is rise over run. Rise over run is looking at a change in the y direction over a change in the x direction. Think about the rise is going up, and y we know is a vertical description. So on the y, to get from one point to the next, I've gone up by 4. That's a positive increase of 4. And so I'm going to keep it as 4 there. Horizontally, I'm moving to the right, which is a positive direction, and that's 6. And so I have my slope as 4/6. Now I do want to reduce that completely. Since that's a fraction, I kind of reduce it to 2/3. And that's, I think, where I want to leave my answer. I don't want to get too fancy other than that. But that's what your slope would be. 2/3 is the slope of that line. Now, let's say we didn't have a graph, we just had a table of values. Well, let's go back to when we originally looked at whether a table showed a linear relationship or not. To get from 2 to 4, I'm adding 2. 4 to 6, I'm adding 2. 6 to 10, I'm adding 4. So I've had a little change there. 7 to 6 is -1. 6 to 5 is -1. And 5 to 3 is actually -2. Now remember in that, what we did is we put the change in the y on top. We're going to do the same thing here. -1 over 2, -1 over 2, -2 over 4. We can see here that all 3 of these are exactly the same. The last one just needs to be reduced, but these are in fact all equal. And therefore, my slope here is -1 over 2. The fact that they're all equal shows me that it's linear, and what it is their slope. My change in y is -1, my change in x is 2. Now that negative, depending on how we did it, could either go in the numerator, the denominator, or out in front of the whole thing. All 3 would be equivalent. What I mean by that is -1 over 2 is the same as 1 over -2, and that's the same as -1/2. Okay, last example requires us to use this formula here. y2 minus y1 over x2 minus x1. You can see from the diagram that x1, y1 is one of our points, x2, y2 is another one of our points. It doesn't make a difference here which point we use as our 1s and our 2s, as long as you keep them consistent. So for this, I'm just going to label them. x1, y1, x2, y2, just to have them labeled there. Now I'm going to go in and find the slope using that equation. y2 minus y1 here is going to be 6 minus -2. That's a big key there, is that it's minus the negative. And then in my denominator, it's going to be x2 minus x1, which is -5 minus 3. Now 6 minus -2 is 6 plus 2, which is 8. -5 minus 3 is -8. And it's going to work out rather nicely there. We can actually get a value for slope, which is just -1. We reduce that fraction all the way, and it becomes -1. So those are the 3 different ways that you can determine slope. If you're given the graph, use rise over run. If you're given a table, look at the rate of change and make sure that it's constant, and that rate of change where it's y over x will work. Otherwise, use this new slope formula, y2 minus y1 over x2 minus x1. And always think to make sure that your slope is appropriately positive or negative. That's a big area that people make mistakes on, so just double check those. All right, now how do we graph with slope-intercept form? Okay, so let's graph this equation, 4x minus 3y equals 6. We could use the intercept method that we had used with standard form, but we're trying to practice something else here. In order to do this, we first want to get it in slope-intercept form, which means getting the y by itself. In order to get the y by itself, I'm going to start by subtracting 4x. Now, because I have the opportunity to do so, I'm going to choose the order that I write these. Instead of writing 6 minus 4x, they're not like terms, so I can't combine them. I'm going to write it as -4x plus 6. Now I'm going to divide everything by -3. division has to happen to every part. Like the distributive property with multiplication, the same thing works for division. This will get my line into slope-intercept form. I'll have y by itself. Negative 4x over negative 3 becomes 4 over 3x, and then 6 over negative 3 is negative 2. So now it's in that slope-intercept form, y equals mx plus b. Now let's identify the slope and the y-intercept. The slope I know is the coefficient of x. That's 4/3. My y-intercept is what's being tacked onto the end. That's negative 2. This is the key information that I need in order to graph my line. Let's get a coordinate grid up here. All right, so I'm going to start by graphing the y-intercept on the y-axis. So my y-intercept is negative 2. That means I'm going to go down to the point negative 2 and graph that point right there. After that, I'm going to use rise over run to find other points. So slope is 4/3. That means my rise is 4 and my run is 3. I'm going to go up 1, 2, 3, 4 points and right 1, 2, 3. I'm always going to run to the right. I'm going to get another point right there. And that's how I would, that's how I could do it. Now the other option would be to go down 4 points and left 3 if we wanted to do it that way. But all we need really is 2 points to form a line, and so now all I have to do is connect them. So I'm just going to draw a line right through here. I'm going to do my best. It may not be perfect, but it will be okay. And I connect through, and I draw the arrows to show that it will continue, and there it is. That's how I graph that line. That's all that it takes. You get your y-intercept, you put it in place, then use rise over run to get other points, and you're good to go. All right, let's bring this to the real world now. So Mr. Callan has $50 on his Dunkin' Donuts gift card, and if he buys one iced tea a day for $1.50, we can actually use a function to model the remaining balance on the card. So to write this function, which I'm going to write in function notation, f of x equals mx plus b, since that's what I'm using, a slope-intercept form. I want to think about what this would be here. Well, my y-intercept is usually my starting point, right? And so that what I'd think about there is my starting point is $50. That's where I'm beginning. And I'm going to buy an iced tea a day for $1.50. So $1.50, thinking about slope might be easier to think about it in terms of rise over run. So we might want to think about that as a fraction, which is 3/2. Now I'm also spending that money, so I'm taking it away from the $50. So it's going to be a negative slope here. I'm going to have negative 3/2x plus 50. Don't worry too much about that right now, how we got that. That'll come in the next chapter. Right now, we just want to be able to graph this. Remember that f of x is the same thing as y, so this is really just slope-intercept form. From this, we know what our slope is. Our slope is negative 3/2, and our y-intercept is 50. So just like we had before, we're going to use that information to graph this line. So let's take a look at what that graph would look like. All right, so looking at this graph, we know our y-intercept is 50, so I could put that up here. And I know my slope is negative 3/2. Now, because we're working with such big numbers, it's not always convenient to use negative 3/2, so I can use an equivalent fraction if I want. I'm going to multiply numerator and denominator by 10 to get negative 30/20. Normally we don't make it more complicated, less simplified, but it's actually probably more useful here, especially because I'm using a little bit of a scale. And so now a rise of negative 30 means I'm going to go down 30. A negative rise would be a decrease, so that's down 10, 20, 30, and then a run of 20 goes to the right. Boom, boom, 10, 20 brings me to the point 20, 20. I would then connect those 2 points and draw them all the way through and get that line there. All right, so what does this graph mean? Let's pick out some key characteristics. First, we have the y-intercept, which is 0.50. That corresponds to my starting point, the $50 that I have on the Dunkin' Donuts gift card before I start buying iced teas. All right, what else is on this graph? The x-intercept is 33.30. It's actually 33.3 repeating, at 33 and a third. Now, what that would mean is that that's how many days it would take before my gift card ran out. Realistically, I know that I can't buy it on a third of a day, so after 33 days, I'd still have a little bit of cash left on the card, and I wouldn't have enough for the 34th day. And so this is something that we'd really have to consider here. Because I'm only buying whole numbers of iced tea, I know that my domain here is actually discrete. So I really should only have a bunch of dots here and not really continue. I definitely don't want to continue this way. This would be negative days or negative balance on my card, which doesn't make any sense. So I definitely have to be only positive values. And I really should have only the dots here, but because of the scale, they're so close together, I'd have a really tough time telling them apart. Now, of all these dots, there's a lot of different things that I could look at. I could figure out my balance at any given day, including at the point that I've already highlighted, 2020. After 20 days, which is my X value, I'd have $20 left on my card. I would have spent $30 in 20 days. And so that's what the different parts of the graph mean. My slope, -3/2, that's the $1.50 I'm spending every day. My y-intercept is $50, that's where much money I'm starting with. My x-intercept, 33 and a third, that's how many days it would take to go all the way through the card. But that's about it. So, hope this makes a lot of sense and that now you can use this going forward.